Its poor little brain. Alright, let me make sure you guys are with me. So you can only multiply by something if it's not 0, and thankfully cosine x is never 0 over the interval that we're interested in. Alright, so it's not going to introduce some answer that is not allowed. So if I factor this, I get
2 sin x plus
so it gets sine x is 0 or cosine x is 1/2. So I get x equals, when is sine x 0? At 0. Or pi, negative pi, but that's outside of the interval. Are you with me? So you don't have to do the plus or minus, the plus pi, 2 pi k stuff or whatever. You guys understand? In this case, it would be pi k. Because I only care about that interval, right? So the other answers are not in that interval. That's the only answer that I care about. Or
Pi over 3.
Pi over 3. 3.
Yeah, 3.
60 degree. You want to get away from the x-axis to make cosine small, because cosine likes the x-axis. Take it away and it goes, oh shit. So that explains that, because it's at pi over 3 and it's at negative pi over 3. So that explains those, but there is a place in the middle where they meet.
Squeeze theorem.
No. So if I graph this, negative pi over 3, pi over 3.
Because negative pi.
Now don't forget. Our functions are here, right?
No.
Doesn't matter what happened when I did identities to solve this. These are our functions. What does tangent x look like?
like little
What's important here?
little things like that.
Yes. And then again, it looks right. And at pi over 3, tangent's what? What's tangent at pi over 3? Rad 3. Rad 3. Good. Because this word's bigger. I like it. So it's let's just put rad 3 there. So at pi over 3 is rad 3, and at negative pi over 3 is going to be negative rad 3. That's crazy. So that's tangent doing its thing. Weehaw. That's our limits anyways. That's all I care about. And now let's bring 2 sine x. Of course, the amplitude there would be 2. So what's at negative pi over 3? What's 2 sine? Well, sine of negative pi over 3 will be 3. I'll see how long it takes you guys to realize. We already know what this is going to be because that's where they meet. Right? So it's going to have the same value. Screw you, Jeff. At 0, sine is 0. That's another place where they meet, right? And then at pi over 3, it's rad 3. But what's it look like between there? It's this here, right?
Oh,
and then that there. I should draw it in a different color, Jeff. Good job, Jeff. Do it in a different color. Let me make sure you guys understand. Because doesn't the sign look like this on this side? Like that? And then it goes like that? It doesn't really, it keeps going to 2, but screw it. It's close enough. You guys kind of with me here? Kind of. Why was that all important? Be very careful with this drawing a little bit, because what's on top of here? The sign. What's on top of down here? So now I realize there is a C, just like that one of the first pictures I have. There's a C. There's a point in the middle where the relationship shifts, which means I have to do what?
2 intervals.
Beautiful. I have to break the interval up according to that point. So what's it going to look like from negative pi over 3, and I'm going to do it in terms of x here. Why am I going to do it in terms of x? Because my functions are functions of x, and I really don't want to solve for x and get arc, tangent, and shit like that. No. So I'm not even going to consider that. Screw that. So it'd be from negative pi over 3 to what? 0. On the top is tangent. And on the bottom is 2 sine x. Plus the interval from 0 to pi over 3. And then this just switches. Because now the sine's on the top. And the tangent's on the bottom. So basically, the nice thing is you integrate this, and that's going to have the same answer, just reversed. You guys understand? Don't look at this like a whole new problem. If you integrate this, you've integrated that. Right? Maybe. Yes, sir.
You should also say when you have two of the same numbers that you can just take one side of it. When you have two even.
Yes, good. I love it. So these are, how do I say this?
Didn't you say that?
These are both odd functions. They're
Yeah.
symmetric, which is the important thing, right? Meaning that whatever this area is, this is
The opposite.
the same area. I love it.
So it's going to be this is turn 0 eventually.
And you could kind of, let's see, we can almost see that there, but not really. So yeah, if you figure out this interval, you just have to double it. I like it. Kick-ass. And that doesn't always happen, though. I want to make sure you understand. So I wanted a general form of something where it has a point in the middle to be careful about. Then you can step back and say, is there something about this interval, maybe the symmetry of it makes it easier to look at. In this case, yes, it does. I just have to do one of them and double it. If you don't see that, who cares? Once you do this, you've done that. It's not like you did a lot more work. Right? So how do I integrate? Well, here's the problem. We did interval a tangent before, but do you guys remember what it was? How do you integrate tangent? Yeah, so remember we did sine over cosine. If u is cosine, du is negative sine. So this will be integral, negative integral of du over u, negative natural log of u. U was cosine. And I showed you that sometimes it's written as this. Are you guys cool with those being the same thing?
Yes.
I'm not saying that cosine equals secant. I'm saying that negative power goes up. That becomes secant, of course, because you flip it. So both of those are the same thing. All right, good. So now that piece is done. So now when I integrate, I've already got that done. It's natural log of secant x. And how do you integrate this? What's the interval of sine? Well, negative cosine, so the negative becomes a plus. So plus 2 cosine x from negative pi over 3 to 0. Become a 3. And again, if you didn't realize the symmetry was there, you've basically done the second integral. It'll be plus 2 cosine x, excuse me, negative 2 cosine x minus natural log of secant of x from 0 to pi over 3. Why do these not cancel? Why don't these cancel? Because you're evaluating with different x's. I love it, exactly. But this actually is a lot more in your face about why I can just double one of them, because this is the opposite sign than this is on its own interval. So it ends up becoming plus plus. It ends up doubling these. If you don't believe me, you can just do it. So what's the secant of 0? 1. And what's the natural log of 1? 0. I love it. 0 plus, and what's cosine of 0? Good, 1, so it'd be 2 times 1 is 2. I like it. So that's when I plug a 0 in. Minus, plug a negative pi over 3 in. What's the secant of negative pi over 3?
1/2. 1 over 1/2, so it's 2.
And it doesn't matter if it's negative or positive because there's absolute value. So it'll be 2. And then what's cosine of negative pi over 3?
1/2 times
Oops, sorry.
2 is 1.
Minus
1.
Yeah, cosine of pi over 3 was 1/2 times 2 is 1, so minus 1. But it's, it's negative pi over 3, but that's still positive for cosine. All right, maybe. So you know me. You know I'm going to throw trig in. So the less you remember your trig values, the worse this is going to be. It's going to take you forever. Because I don't want to see no freaking decimal shit. Aw. Oh, Jeff.
Oh, curses.
I'll just take a negative out of there, just to make it easier. 2, so is every cola I took a negative out?
Yeah, it's alright.
So now it's 20, thank you so much. Cosine of pi over 3 is still 1/2 times 2 is 1. And some of you guys might realize we're going to get the same stuff here, but let's just go for it. Plus, when you plug a pi over 3 in the secant, you still get...
2.
Why did I do... This should be ln 2, that's right.
Yeah.
My bad. So you just go ahead and yell at me when it happens. I was like, wait a minute, it doesn't sound right. And then when I plug a 0 in, cosine of 0 is 1. And secant of 0 is 1. So that's 0. So then you get, let's see, 2 ln 2 minus 3 minus... Did I make a mistake somewhere? You probably did, Jeff. I don't know. I get a feeling like they made a mistake with the 2's there, but oh well, maybe not. Negative 1, let's see, negative 3 plus 1 would be negative 2. I don't know if that's quite right. You can check me on my signs there, but... Oh. Gross.
Is negative.
So let's see.
No, it's still minus.
Good negative out, so that's it. And then minus 2. That looks... Oh, I did. Oh, I see what I did. Alright. My bad. So, plug a pi. No, I did alright. You plug a 0 in. Power of 3 plugged in. Plug a 0 in, so now it should be minus 2. And then minus 0. Yeah. That's right. Freaky.
Should the ln's of 2 cancel? So it's a negative.
Oh, why did I do that? That's not quite what I expected, but it's alright.
Yeah.
That can't be right. Something went wrong there. Oh well. Went too fast through that. Screw it. I'll have to look at it. It should be, obviously, it's got to be positive. The answer's got to be positive. So I just made a negative mistake somewhere. So I'll look at that one again. Which one was that? That one. Okay.
We could watch the video anyways.
Yeah. Alright, so tomorrow we'll get into section 6.2. I highly recommend, if you've never tried this before, to read ahead a little bit. It's amazing what it does for you.
A short video of
So, all the more reason to read ahead.
He goes into a lot of more questions.
I have 2 Java projects today.
Oh no, I see what I did. I put the L in the wrong place. L's there. So it'll be 4. That's all I did. Should be there. 1 plus 1 is 2. So 2 minus 2 L into 2. Okay. The LN, add it there. Should be there. It works out.